Another session of ham radio exam preparation is here with multiple choice questions followed by discussion with illustrations. The transformer works on the principle of A. Self-inductance, B. Mutual inductance, C. Both A and B, D. None. Transformer works on the principle of mutual inductance for transforming voltage, current and impedance. It has a primary and a secondary coil with magnetic flux linkage. Alternating current passing through one coil induces a current in the other coil. The two coils can be wound one on top of the other or on two limbs of a continuous magnetic core, typically a laminated one, to prevent eddy currents. Alternate option is a toroidal transformer wound on a ferrite toroid. Voltage in the secondary winding is related to that in the primary winding according to the ratio of number of turns on both sides. If the primary winding has more turns than the secondary winding, it acts as a step-down transformer and vice versa. Here is a step-down transformer used in linear power supplies with outer cover removed to show the laminated core inside. Circuit mounted on the breadboard is a bridge rectifier along with a high-value filter capacitor to smooth out the ripples in the rectified direct current. This picture shows different types of inductors which work on the principle of self-inductance. Couple of them are wound on toroidal cores while another is wound on a ferrite rod. Inductors are used in tuned circuits and band pass filters in radios. The frequency of oscillation of a series resonance circuit is A. F equal to 1 by 2 pi into root of LC, B. F is equal to 1 by pi into root of LC, C. F equal to 2 pi into root of LC, D. None of the above. When an inductor and a capacitor are connected in series, the reactance of the inductance tends to cancel the capacitive reactance. So the total reactance will be the difference between the inductive and capacitive reactances. Reactance of the inductor is directly proportional to the frequency, while that of capacitor is inversely proportional. For every combination of inductor and capacitor, there will be a frequency at which inductive reactance will fully cancel the capacitive reactance. That will be the resonant frequency of the combination. If the resistance in the circuit is negligibly low, then current can go very high at resonant frequency. Resonance for a particular frequency can be achieved by varying the capacitance of a variable capacitor to match the reactive inductance of a coil for the frequency to be received. At resonance, inductive reactance 2 pi FL is equal to 1 by 2 pi FC, the capacitive reactance, where F is frequency, L the inductance and C the capacitance. In a series resonant circuit, the impedance is lowest at the resonant frequency. Frequencies quite away from the resonant frequency have a high impedance and will not pass through a series resonant circuit. Resonant circuits are used in frequency filters. Series resonant circuit allows the resonant frequency to pass through, while a parallel resonant circuit blocks the resonant frequency. The capacitor is A. Passive device, B. Active device, C. Both A and B, D. None of the above. Passive devices are electronic components like resistors, inductors, transformers and capacitors. They do not alter the waveform of an alternating current applied to them and hence cannot be used to amplify or rectify currents. Passive electronic components do not require an external power source and can store, dissipate or consume energy in a circuit. Active devices are vacuum tubes, semiconductor diodes and transistors, or a combination of active devices and passive devices like integrated circuits, which require an external power source. They can change the waveform of an alternating current applied to them and hence can be used for amplification and rectification. They can also generate signals. Bridge rectifier is A. Full wave rectifier, B. Half wave rectifier, C. Both A and B, D. None of the above. Bridge rectifier is a full wave rectifier which uses 4 diodes instead of 2 in the usual full wave rectifier and 1 diode in a half wave rectifier. The full wave rectifier utilizes both halves of the input alternating current cycle, unlike half wave rectifier which utilizes only one half cycle. The image shows a step-down transformer, schematic of a bridge rectifier and 4 diodes mounted as a bridge along with a filter capacitor on the breadboard. In the process of modulation in a radio communication system, A. Signal frequency is more than carrier frequency. B. Signal frequency is less than carrier frequency. C. Signal frequency will be directly transmitted. D. Signal frequency equals carrier frequency. In a typical radio communication system, the carrier frequency is the radio frequency range, which is much higher than the signal in the audio frequency range. Human voice has a frequency in the range of 20 Hz to 20 kHz. Most amateur radio signals have frequency in megahertz range, like 3.5 MHz for 80 meter band, 7 MHz for 40 meter band, and 14 MHz for 20 meter band. VHF or very high frequency amateur radio band uses frequencies in the range of 144 to 146 MHz in India. All these are much higher than the audio frequency range. This is an animated diagram illustrating the difference between radio waves modulated by amplitude modulation and by frequency modulation. The vertical axis represents the amplitude, either voltage or current of the signals, and the horizontal axis represents time. The top graph is labeled signal is the modulation signal, voice signal in case of usual radio transmissions, applied to the transmitter in this simple example of a sinusoidal wave. Actual audio from a human voice will have multiple frequencies. Only the extremely low frequency ELF electromagnetic waves used for submarine communication comes in the range comparable to audio frequency. But they do not send voice modulated signals. Instead, they use a form of frequency shift keying to transmit information at very low speeds.